This is problem 6e on sample test 1. This is a break-even analysis problem, and they were introduced to you in lesson number 6. And specifically, the first class activity exercise was a problem similar to this. If you'd like to go to our text and read more about break-even analysis problems, you'll find that in section 5.1. So it says here, a company that manufactures running shoes has a fixed cost of $300,000. Additionally, it costs $30 to produce each pair of shoes. They are sold at $80 per pair. So the first thing it asks us to do is to write a cost equation, capital C, of manufacturing X pairs of running shoes. 2, write the revenue equation, capital R, from the sale of X pairs of running shoes. Then determine the break-even point and describe what that break-even point means in the context of this problem. So remember, the break-even point is how many pairs of running shoes will I have to both produce and sell in order for the costs and the revenue to be equal? So at what point will the money I put out equal the money I take in? That's the break-even point. So one of the first things you should realize here is that you will be finding the coordinates for a point. Okay, you'll be finding the coordinates where the first coordinate X is the number of pairs of running shoes. And the second coordinate is going to be what you typically call Y, is going to be both the cost and the amount of the cost and the revenue to produce and sell this many pairs of shoes. So we're looking for 2 values here, not just one. All right, so let's take a look. Part 1 says, find the cost equation. Well, let's go back up and highlight what parts of this particular problem deals with cost. So right here we have a fixed cost of $300,000. So that's where we're going to start, because regardless of whether we ever make one pair of running shoes, my company has put out $300,000. Additionally, it costs $30 to produce each pair of those shoes. So that's your variable cost, $30 per pair of shoes times the number of shoes, which is represented by X. Okay, 2, write the revenue equation. Let's go back here just for a second and give ourselves a little space and take this out here. So that was just at the beginning. All right, so now let's write the revenue equation, which is how much money the company takes in from selling X pairs of shoes. So it's going to cost them $30 for each pair, but they get to sell each pair at $80 per pair. So this is the revenue and this is the cost. And this is our system of linear equations. Okay, of linear equations. All right, so how do we solve this? Well, we know that at the break-even point, the costs and revenue are going to be exactly the same. So you want to set up an equation, what equals what, and that's when the cost equals the revenue. And using our technique of substitution, wherever you see C, you can replace it with the expression 300,000 plus 30x, and wherever you see R, you can replace it with 80 times X. So let's do that, and then we'll have an equation with one unknown, and we can solve it for X. So we have 300,000 plus 30x equals 80x. So we're going to solve this equation for X. Solve for X. So we subtract 30x from both sides. And we left with the constant 300,000 on the left side and 50x, the variable term on the right side. Now to solve this, we divide both sides by 50, and we get 6,000 equals x. So remember, x was the number of running shoes that were both produced and sold. So we know now that the first coordinate of our break-even point is $6,000. And now we want to find the cost and revenue when we make and sell $6,000. So it doesn't matter which of these original equations you go back to, because they should both produce exactly the same answer. So if we take 300,000 and we substitute for x 6,000, that will give us $480,000. If we take the revenue equation, 80x, and we put in 6,000 for x, you see we'll also get 480,000. So that is the break-even point, 6,000, comma 480,000. Okay, what does this mean in terms of the context of this problem? What this means is that the companies, you can basically look at this equation and just write your sentence just like what that tells you. It means that the company's costs and revenue will both the cost and revenue will both be, and now you use your units, $480,000. And when does this happen? When 6,000, and what's the units on the 6,000? Pairs of shoes are produced and sold. And that's it. It's always nice to have a visual for the algebra that you create. And in this problem, you can see that this red line represents the cost equation that we wrote a few minutes ago. It starts at 300,000 and it increases at $30 for each pair of shoes that's produced. And here's the equation up here. And then the revenue starts at 0, since we take in no money if we produce no shoes. And it starts to increase at a steeper rate until we get to our intersection point, 6,480,000. And from that point on, you can see that your revenue is greater than your cost. And it's at this part of our graph, beyond 600,000. So when X is greater than 600,000, the revenue, when the X is greater than 6,000, the revenue is greater than the cost. So that's when the company will make a profit. Okay, so that happens everywhere in this region, right in here. This is when the company makes a profit, beyond 6,000 pairs of shoes. Prior to that, the company was in the red down here. Try to make that red. There we go. So when X is less than 6,000, the cost is greater than the revenue. So here we're losing money, it's a loss, and here we're gaining money, it's a profit. Okay, I thought you might find that visual helpful for the algebra we just produced. Let me know if you have any questions.